morning, everyone. I'm going to talk about wireless energy transfer. And today's agenda is introduction, following by technology, then talking about size, power, and efficiency of the components, then the three methods of transferring energy, and finalizing with the future of this technology. Now, what is wireless energy transfer? The electrical energy is transferred from a power source to an electrical load without interconnected wires. The goal is to generate an effect locally and be detected at a distance. Now, I want to make sure that you not make the mistake of confusing information transfer and energy transfer. Because for the information transfer, the percentage of the power that is received is only important if it becomes too low to successfully recover the signal, as we saw in class. For the energy transfer, the efficiency is a more important parameter. Now, how this technology works? We have a circuit A that is connected to a wall circuit, meaning that is connected by wires. So the current reaches the circuit at hertz, in this case 60 hertz. And this circuit will convert it to a higher frequency of megahertz, in this case 10 megahertz. Then we'll feed this transmitting coil with the same frequency, and then with this coil we'll generate a magnetic field that will be detected by the receiving coil. Now, not until it reaches this circuit, it will transform this 10 megahertz into 60 hertz, and then we'll feed this bulb or any kind of electronic device. Now, the size of the components is determined by the distance from the transmitter to the receiver. Also, the wavelength of the radiation and the laws of physics, especially the diffraction limit. This diffraction limit says that any beam will spread out and become weaker if it gets to it's transferred for bigger distances. So the larger the transmitting antenna, the tighter the beam, and the less it will spread out as a function of distance. Now, for the power levels, we combine these above parameters together, and then we add the gains and losses due to the antenna characteristics and the transparency of the medium. This process is called as calculating the link budget. For the efficiency, it is calculated by having the power that reaches the receiver minus the power that's supplied from the transmitter. As I mentioned, it suffers from dispersion to the environment, so it works best at shorter ranges. This is an example. Let's say we want to transfer 10 megajoules of energy from one place to another. To calculate efficiency, we have to consider several things like the transmission and atmospheric losses, also the current laser and solar cells efficiencies. Now, the three methods to transfer the energy are in different ranges: the short, the medium, and the long range. For the short range, it's a few centimeters, and it's called electromagnetic induction. The energy will be transferred by electromagnetic coupling through the process called mutual induction. Now, I mentioned that it's possible to transfer energy from one place to another place longer distance, but in this case, to power the two inductors, they must be really close together, like in the photograph. And there are current use applications of this method, like the electrical two-cross battery charger, the induction cooker stovetop that most of us have in our apartments, and then the artificial heart, like the field port and other surgically implanted devices. This is the second method, a few meters, and it's called evanescent wave coupling. This method is using a non-radiative electromagnetic energy resonance tunneling. Through testing, they come up with a 60 and 70% efficiency. Now, how it works is as I explained before. By wires, the the electricity is transferred to the main antenna, to the transfer antenna. Then this antenna will generate the electromagnetic field that will reach the receiving antenna. And this will help recharge any kind of devices. Now, the good thing of this method is that any energy that is not fully transferred to the receiving antenna, it will be reabsorbed to this antenna, to the transmitter, so objects and people are not affected by it. And the third method, the long range, is multiple kilometers, is radio and microwave. Now, there is a Japanese scientist called Hidesugu Yagi. He designed a directional antenna. Now it's called Yagi antenna. How it works is that the power transmission is via radio waves and can be more directional, allowing longer distances and then having a shorter wavelength of electromagnetic radiation, typically in the microwave range. So the antenna at the receiving end will convert this microwave energy to electricity. So the antenna has been proven to have exceed an efficiency of 95%. Now the future of this technology. I mentioned before for the first method is already in use, but for the second and third, it's in process of development. I'm going to talk about first the third method. Although it hasn't been proven, we could combine the electrical power transmission across the broadcasting and the wire telecommunication that we saw in class, eliminating many of the existing high-tension power transmitter lines, and facilitate the interconnection of electrical generation plants on a global scale. Now, as for the second method, we could change the gasoline stations into the energy transmission for public transportation first, and then in the future for personal cars. So how this works is that the bus will arrive to the bus stop, and this the transmitter resonator will generate these electromagnetic waves, and will be captured by this by the receiving resonator. And then this will take a few seconds because the bus will just stop for a few, right? But if together with other technology, the energy can be stored at the top here, you see, at the top of this of the bus until it reaches the next station or it really needs it. Another application for this technology, for this method, is to charge any kind of electronic device. Let's say in the house, in the kitchen, at the car, in the office, anywhere, eliminating any kind of wires. And then, but this technology cannot be done until it becomes a standard in any electronic device. So this technology only becomes, only stays a dream if it doesn't become a standard. Thank you very much.
Very good. Questions? I think it's a very comprehensive review. Certainly it's coming by, this kind of technology. So,
yeah, actually Fulton is already developing the technology to charge all the devices, the computers,
yes.
like anything.
Yes,
It's
yes,
really
yes. It's actually quite realistic. It's coming by before we know it, I guess. Any other questions? Okay, thank you.